watched the video and you created the population growth charts for the honeybee population and mouse population, let's go over what you've learned so far. So I see that these two graphs look a little bit different, so let's find out why their growth was different for these two populations. So what do these numbers here represent?
The honeybee population.
Okay, so can we label that? And these numbers here?
The days.
And for the mice population, these numbers?
How many mice?
Okay. And these numbers here?
The generations of mice.
Very good. So all of the mice generations. So I think that your graphs look excellent. Let's look over them and figure out what kind of growth happened in these populations. So for the honeybee population, I see that it kind of leveled off here. So what happened on these last few days?
The population stopped growing.
It stopped growing. And when did it stop growing?
On day 35.
35. And what was the highest number it reached?
320.
320. So what happened on day 35? What kind of growth did it reach? Logistical or exponential growth?
Logistical.
Logistical growth. Good. Can we label that as well? So if it reached logistic growth on that day, why do you think the population stopped growing at that time?
It was its carrying capacity. Maybe there was a limiting factor.
What limiting factor could have happened?
Maybe like a storm or an earthquake or something different.
Yeah, that's right. So the population stopped growing. And I like how you used carrying capacity. That's true. So that's when the habitat reached its limit and no more population growth for those honeybees. Now let's look at the mice population. So I see that the numbers keep going up and up. So what's happening there?
The population didn't stop growing, it just kept increasing.
So it kept increasing. So is that exponential or logistic growth?
Exponential.
Good. Can we label that as well? So if the population for the mice keeps growing and growing, what do you think the population is going to look like in the 110th generation?
It's gonna keep growing, maybe 20,000 more or so.
That's right, because it keeps getting so high, as we can see, that population is just like booming. So I have a few questions about what you learned from your graphs and from the video. So number one would be, what type of growth pattern is exhibited by the honeybee population? Is it the same type of growth as the mice population? And explain your answer. So you can answer that now.
So the honeybee growth would be logistical growth, and it's not the same as the mice population because it stopped growing.
Good. And number two, does either graph indicate there's a carrying capacity for a population?
Yeah, the honeybee one.
Okay, that's right. And if so, when does the population reach its carrying capacity?
Day 35.
And what is the maximum number of individuals that could be supported at that time?
320.
Good, so that's the carrying capacity. Now this is a prediction for the mice. So animals such as coyotes and cats often prey on mice. Based on the growth curve of the mice population, what might happen if the group of predators move into the mice habitat during the 10th generation and begin eating the mice? So what would happen if
The population stopped growing and possibly decrease.
Yep, that's right. Thank you, Yesenia. So we have two different populations here, and it really seems like you understand these two types of growth. Thank you.